Dear student, welcome. Myself Dr. S.K. Gupta. Today I am going to start with topic application of Newtonians. This topic is very important for Iit-Jams and CSIR Net-Jrf. First application, determination of wavelength of the light. First we obtain of the Newtonians by Newtonians experiment diagram. It is a Newtonians experiment diagram. We obtain of the Newtonians. That is a Newtonians. dn is a diameter of the nth dark Newtonians. dn n plus p is equal to diameter of n plus p dark Newtonians. R is the radius of the curvature of plano-convex length. P the order of the difference too dark either too bright Newtonians. Lambda is the wavelength of the monochromatic light. It is Newtonians. dn is the diameter of nth dark Newtonians, and dn n plus p is the diameter of the n plus p dark Newtonians. Diameter of the nth dark Newtonians we have already calculated my previous video lecture. dn is equal to 2 under root n lambda r. Now equation 1. Diameter of n plus p rings is dn plus p is equal to twice under root n plus p lambda r. That is equation 2. Square in of equation 1 we get dn square is equal to 4n lambda r. That is equation 3rd. Square in of equation 2 we get dn plus p square is equal to 4 n replaced by n plus p. So 4n plus p lambda r. Now equation 4. Subtraction of equation 4 from equation 3rd, dn plus p square minus dn square is equal to 4 n plus p lambda r minus 4 n lambda r. After solving that, 4 n lambda r plus 4 p lambda r minus 4 n lambda r. 4 n lambda r, 4 n lambda r cancel out. dn plus p square minus dn square is equal to 4 p lambda r. So lambda is equal to dn plus p square minus dn square by 4 p r. Is that clear? So we find out of the wavelength of the monochromatic light with the help of the Newtonians. Now first we obtain of the Newtonians by the Newtonians apparatus. Number 1. Number 2, find out the diameter of the nth order of the dark Newtonians and n plus p order of the dark Newtonians. Is that clear? So the 3 steps we calculate the wavelength of the monochromatic light with the help of the Newtonians. Now second application, determination of the refractive index of the liquid. Is that clear? The liquid whose refractive index is to be determined is filled in the gap between the plano-convex lens and glass plate. Is that clear? We know that the path difference of two reflected rays reflected from bottom surface of the plano-convex lens and upper surface of the glass plate, that is delta is equal to twice mu t cos r plus theta minus lambda by 2. Is that clear? We change of the medium, the path difference between two reflected rays is also changed. Path difference is changed. Condition for dark and bright Newtonians is also changed. And diameter of the dark and bright Newtonians is also be changed. Is that clear? So when a oil drop put bottom surface of plano-convex lens and upper surface of the glass plate, to what happen? Change of the path difference, change of the diameter of the dark and bright Newtonians. Is that clear? So change of the diameter, d dash n is equal to diameter of nth dark Newtonian. So d dash n is equal to twice under root n lambda r by mu. Mu is the refractive index of the liquid put bottom surface of the plano-convex lens and upper surface of the glass plate. N order of the Newtonian does not change. Lambda wavelength of the light incident on plano-convex lens and glass plate does not change. R is the radius of curvature of plano-convex lens is not change. What change of the medium? So the diameter of the Newtonians is also changed because the diameter of the Newtonians is inversely proportional root of the refractive index of the liquid. So change of the diameter n plus p is equal to diameter of n plus p as dark Newtonian. So d dash n plus p is equal to twice under root n plus p lambda r by mu. Is that clear? Now squaring and subtraction of these two equations, d dash n plus p whole square minus d dash n whole square is equal to 4p lambda r by mu. That is equation 1. For the air medium, difference in the square of the diameter of ns plus p and ns dark Newtonians is found already in my previous video lecture. Then dn plus p whole square minus dn square is equal to 4p r lambda. It is equation 2. Dividing by equation 2 by equation 1, we get the dn plus p whole square minus dn whole square y d dash n plus p whole square minus d dash n whole square is equal to refractive index of the liquid. Is that clear? So we have learned of this topic. Number 1, change of the refractive index. So change of the path difference. Change of the path difference, condition for dark and bright Newtonians also change, and change of the diameter of dark and bright Newtonians, and also change radius of the dark and bright Newtonians. Is that clear? Now the numerical problem. In a Newtonians experiment, the diameter of the 15th range was found to be 0.59 cm and that of the 5th ring is 0.336 cm. If the radius of the curvature of the lens is 100 cm, find the wavelength of the light. Any numerical solved by the 3 steps. Number 1, what is given it. Number 2, what is find out, and relation between given it and find out, that is a concept. The given data are diameter of the Newton in 15th range is equal to 0.59 cm. Centimeter convert to meter is divided by the 100. So 0.59 into 10 to the power minus 2 meter. Diameter of the Newton 5th range is equal to 0.336 cm. Convert in meter divided by the 100. So 0.336 into 10 to the power minus 2 meter. Radius of curvature of the lens is equal to 100 cm is equal to 1 meter. Wavelength of the light is find out. So lambda is equal to dn plus p square minus dn square by 4pr. P is the order of the difference of the two dark rings, either two bright rings. So put the value of b d square n plus b is given it 0.59 into 10 to the power minus 2 whole square minus 0.336 into 10 to the power minus 2 whole square by 4. P is 10 into r is 1. The solve of the whole values, we get of the answer 5880 Armstrong. So we have calculate the wavelength of the light by 3 steps. Number 1, what is given it, what is find out, and relation between given it and find out. Any numerical solved by these 3 concepts. Next, Newtonians are observed in the reflected light of waves of wavelength 5900 Armstrong. Diameter of 10th dark ring is 0.5 cm. Find the radius of curvature of lens used. Is that clear? The given data are wavelength of the light is 5900 Armstrong. 1 Armstrong is equal to 10 to the power minus 10 meter. So 5900 into 10 to the power minus 10 meter. Diameter of 10th Newtonians d10 is equal to 0.5 cm is convert of the meter divided by the 100. So 0.5 into 10 to the power minus 2 meter. Radius of curvature of lens is find out. The formula d square n is equal to 4n lambda r. So r radius of curvature is find out. So r is equal to dn square by 4n lambda. Put the whole value in these equations, we get 1.059 meter. So radius of curvature of plano-convex lens is 1.059 meter. Is that clear? Next, calculate the thickness of the air film at the 10th dark ring in a Newtonian system viewed normally by the reflected light of the wavelength 500 nanometer. The diameter of the 10th dark ring is 2 millimeter. Is that clear? Given data, wavelength of the light lambda is equal to 500 nanometer. 1 nanometer is equal to 10 to the power minus 9 meter. So the 500 into 10 to the power minus 9 meter. Number of the dark ring viewed n is equal to 10. diameter of 10th dark ring D10 is equal to 2 millimeter or 1 millimeter is equal to 10 to the power minus 3 meter. So 2 into 10 to the power minus 3 meter. Radius of it 10th dark ring is equal to radius is equal to half of its diameter. So radius of its 10th dark ring is equal to d10 by 2 is equal to 1 into 10 to the power minus 3 meter. We know that the diameter of a dark Newton ring dn is equal to under root 4n lambda r. Is that clear? dn square is equal to 4n lambda r find out. So r is equal to dn square by 4n lambda. dn square is given 2 into 10 to the power minus 3 का whole square by 4 and 10 into lambda 500 into 10 to the power minus 9. So after solving we get of the value of the radius of curvature of plano-convex length 0.2 meter. T the thickness of the Newton ring, T is equal to Rn square by 2r. Rn is the radius of the Newton ring 10 to the power minus 3 का whole square by 2 into 0.2. After solving that is equal to 2.5 into 10 to the power minus 6 meter. 10 to the power minus 6 meter that is micrometer. So 2.5 micrometer. So thickness of the Newton is equal to 2.5 micrometer. तो 10 to the power minus 6 मीटर इज इक्वल टू माइक्रोमीटर. इट इज क्लियर? ठीक है दोस्तों, आज मैं आपको एप्लीकेशन अभी न्यूटन इंच मैंने यहाँ तक कराया है. मैं उम्मीद करता हूँ आपको यहाँ तक समझ में आ गया होगा. अब मेरा जो नेक्स्ट वीडियो आएगा उसमें माइकल से इंटरफेरोमीटर में लेके आऊँगा. ठीक है दोस्तों, मेरे चैनल को लाइक कीजिए और शेयर कीजिए, और जितना ज़्यादा अपने स्टूडेंट को शेयर करोगे उतने ही स्टूडेंट इसका लाभ उठा सकेंगे, अपनी प्रॉब्लम को सॉल्व कर सकेंगे. ठीक है दोस्तों, नमस्कार.